Hey, welcome back to C64 Old School Retro. Today we're going to build the C64 Bridge project. It's a wireless USB keyboard/HIT emulator for the Raspberry Pi Zero 2. And it comes with a serial bridge that can be used with the Vibe C64 project. Basically what it does is it sends remote keystrokes to the Commodore C64 Ultimate. I'm going to run you through how to build it up, set it up, and test it out. Okay, just going to quickly talk through the hardware. The main piece of hardware for this project is a Raspberry Pi 2W. The W is important. You can just get this anywhere locally. I got mine from Core Electronics. They're a great mob here in Australia. Not sponsored, but love the work that they do. Very cost effective. We're going to need an OTG cable. In my case, I couldn't get an OTG cable, so I got an OTG shim. An SD card to store the Raspberry Pi OS, and the OTG shim was just basically something that I could get. If you had the right cable, you could just use an OTG cable and plug that right in. You wouldn't have to use the shim. Very simple unit, easy to put together, very cheap and very cost effective. So let's assemble it. Okay, here's the Raspberry Pi all assembled. Just a cheap $5 case that I got again from Core Electronics. The only thing that you really got to take care of is you've got to make sure you're plugging the OTG cable into the data port. So there's a couple of ports on the Raspberry Pi Zero. The data port is the second port if you're looking at it in this picture, just here. So make sure you're plugging your OTG cable in there. Obviously pop in your SD card after you've imaged it, but yeah, it's very important that you get the data port right and then plug that other end of the cable into your C64 Ultimate. Okay, pick your favorite Raspberry Pi imager. This time I'm using Raspberry Pi imager on Arch Linux. Here, pick the correct model of the device that we're going to set up. It's very important for stability that we choose the Raspberry Pi Lite OS 32-bit. Apparently this is more stable for Gadget type cases, which is really what we're interested in. Choose your SD card, make sure you're choosing the right card. Give your host a name. I'm just calling C64 Bridge Project. Obviously, do any localization or customization here. Very important, set up a username and a strong password. Make sure you remember the username and password, otherwise you'll have to go through this imaging process again. Alright, pick your network. In this case, I've blocked out my SSID. Hopefully you have a strong password. Really need to get this connected to the Wi-Fi. It's just so much more useful to be able to remotely transmit the keystrokes across the Wi-Fi. Very important, we need SSH enabled for this setup, so make sure it's enabled, and I'm just using password authentication, and I never really bother with Raspberry Pi Connect. Here we can see the summary. We've got Raspberry Pi Zero, 32-bit OS Lite, we've got the right card, and we're basically ready to write it off to the disk, and this will take a little bit of time. Alright, and the image is written and we're ready to go. We can see here that it's all configured. Wi-Fi is configured, SSH is enabled, we've picked the right OS. We're ready to get into the setup. Okay, all the steps you need are over on the GitHub page, links in the description. We've already gone through a brief overview of the hardware that you need, but there's an example with some links there. There's everything that you need to kind of get it going, step-by-step instructions, including how to set up the OS, but we're going to focus on actually getting the Raspberry Pi 2 up and running and enabling Gadget mode now. So first step is to SSH into your host, get that set up, then we're going to update all the packages. The package update is going to take a fair bit of time, so we'll just fast forward through this, but log into your device. It will be slow on the first login. It's a low-powered device, don't expect too much, and also be patient when you're rebooting. If you don't know the IP address or if the name doesn't work, just check your router, but in this case I'm using Linux and I know that it's 1.99. I've tried to make all the instructions really easy to follow, so just copy and paste here. First step is to just simply update all packages and reboot Raspberry Pi and get that OS in a good condition. So we're going to do that now. Okay, now that the OS is all updated, we're going to enable Gadget mode. Again, I've tried to make the instructions really simple and a little bit of just copy and paste. And I've tested these instructions many times, but if you find any errors, just let me know and I'll update it. But basically what we need to do is enable the Gadget mode, set some kernel parameters. I know that sounds a little bit scary, but if you just follow the instructions, it'll be just fine. And again, just copy and paste. Now we're just going to make sure the kernel modules we need are loaded at boot time. So again, copy and paste. I've tried to make it easy, and you don't have to copy and paste. You can do this manually if you want and just read the instructions. If you don't trust the copy and paste, that's fine. Got to make these changes permanent. And then you'll see through the instructions we reboot a couple of times, and that's just to make sure that we're going through this step by step at a steady rate and we're not introducing any errors, and you kind of end up with a working device that's running perfectly. And again, be patient with the Pi Zero. It's a low powered device. It's going to take a little while to reboot. Okay, we're back into the Pi. After a couple of failed login attempts, we're just going to check that the devices that we need exist. So just copy and paste this command, we can see that it's there. Then we're going to configure the Pi Zero for USB gadget mode. This is just pretty straightforward. Again, try to automate this for you, but you can do this manually. But, you know, have a look through the script, and if you like it, just copy and paste it straight into the shell, and it will configure it for you. Okay, we're just going to create two quick scripts now. One to bring the gadget hit down and one to bring the gadget hit up. And basically set up a systemd service to make sure that starts automatically when the Pi boots every single time. And then we're just going to troubleshoot that and see if that's enabled and there's any errors. So again, the command is just here. We just want to invoke systemctl and have a look at the output and make sure we get a lot of green on the screen. Okay, it's all looking good. When your issues are enabled and active, we're gold. We're just going to reboot one more time to make sure that these changes are persistent because we need everything to work. And we'll continue setting up the actual network code next. Okay, we're back up and running. I'm just going to do one final check, make sure we're still in gadget mode, and then we're going to install the network daemon that I created. It's a very, very simple Python script that basically acts as a little network service and takes in keystrokes and then passes those keystrokes through to the Commodore 64 Ultimate, allowing any of your projects to manually type on the Commodore C64 Ultimate. I haven't tested it on the C64 Maxi, so I'm not sure if it'll work, I mean, it will work on any PC, but specifically this project is designed to send those keystrokes through to the Commodore 64 Ultimate, and only works with that at the moment. So what we're going to do is just paste that daemon across. As you can see, we're just going to make this executable and change the permissions, and then what we're going to do is just create a small configuration file. You'll notice this configuration file is set to listen on 000, and here we have a password of I love my Commodore C64. Do change that to whatever you want to for your network conditions, and always try to be secure when you're doing things on the network. Just remember that this could expose a service, and if you want, you can tweak these parameters. Once that's done, we're just going to basically create a startup script to bring the service up and running, and then we're going to execute the start and reload of the service and just see if it works, and then basically we're done. Okay, we're just enabling and starting the service now, and there's a great command here just for troubleshooting. Journal CTL. If you have any issues and you need to debug the project, you can just use this command, but in the background there we've started the Daemon with system CTL, and hopefully it's all green. There you go. That's basically the entire project set up from end to end, and next we're going to move on to testing the project. Here I'm just doing another quick reboot to make sure everything end-to-end comes up, just out of an abundance of caution. You can skip some of these steps if you like, but I just like to make sure that everything's working. Okay, after reboot we can see that everything's still up and running, so we're basically done. Now it's time for the fun part of the project, and getting in and testing. Here I put down, you can shut down if you need to plug in cables or plug in the device, but I've got a couple of test scripts here. One is a simple hello world, but my personal favorite is I love my Commodore, which we're going to test on the C64 Ultimate together. Okay, just a quick little test script that we're going to use here, so we can see that everything's working on the Raspberry Pi. We're going to exit out the Raspberry Pi and copy this quick test Python script to the local computer. I'm using Linux, this is all set up for Linux, and I'm using Bash, this is all set up for Bash as well. And so we're going to exit out of the Raspberry Pi now, paste this in, we're going to go and customize this Python script. Very important that you customize the network host to be your Raspberry Pi device, and the port if you changed it, and hopefully a secure token aka password. Those of you who grew up with Commodore will recognize this script, and we're going to test it on the Commodore Ultimate now. Okay, we're just running the script on my local Linux box, and we're hoping it's going to relay these keystrokes to my Commodore C64 Ultimate. And there we go, there we have it. The C64 bridge project's all set up, and I think that's enough for this video. Thank you all for watching, and next video we'll talk about how to get the C64 bridge project working with Vibe C64. Thank you very much.